Okay, now let's move on to question 3. Question 3 is again the wave equation, right? So I'm again going to summarize the question, right? So question 3 again is a wave equation, and as with all wave equations, you are given two boundary conditions, boundary condition 1 and 2, okay, which tells you what happens at the two boundaries at x equals to 0 and at x equals to 1, right? So the two ends are x equals to 0 and x equals to 1. And also two initial conditions, initial condition 1 and initial condition 2. Okay? Alright, so let's start. So as usual, since it's the wave equation, okay, you can just go to your formula sheet and find that the general solution to the wave equation is this. Right? So this, which I call equation 1, is actually the general solution that's copied directly from the formula sheet which will be provided to you. Right? So this one. Okay? Right, so same thing, we can now start applying the boundary conditions, okay, to find out what all these unknown constants h, I, j, k, a, b, c, d are. Right? Now, you will notice that the first boundary condition tells you what du dx is. Okay, so we first need to find what's du dx. Okay, so from equation 1, you can tell that du dx. Okay, so I'm just going to differentiate equation 1 with respect to x. So when you differentiate equation 1 with respect to x, ix just becomes I. Right? So you have j plus kt. Okay, then over here you will find that your cos will then becomes a minus sign, right? So and you have to take out the w over c. So I'm going to take out the w over c and bring it right out. So it's w over c. Okay, so a cos, when you differentiate with respect to x, becomes minus sign. So the minus sign is here. Notice the w over c I have taken it out of the bracket. Same thing, when you differentiate this sine term, it becomes cosine. Right? Right? You need to multiply by a w over c, which I have already done by taking it out of the bracket here. Right? So this c and d terms, you don't touch them because they are functions of t, not x. Okay? You are differentiating with respect to x. Alright. Okay. So now you are ready to put in your first boundary condition. Right? So I'm going to put boundary condition 1, which tells me that du dx equals to 0 at x equals to 0. Okay, copying from here, and I'm going to put it into equation 2, right? Du dx. Okay, so I just, in this equation I put x equals to 0. Right, so x will become 0 here and here. So if I, j plus kt plus omega over c minus a sine, okay, when you put x equals 0 here, it's just sine 0 plus b cos, when you put x equals to 0 inside here, becomes 0 times c cos omega t plus d sine omega t. Alright? And again, this has to be equals to 0. Right? Equals to 0. Right? Now again, this has to be equals to 0 at all values of t. Right? So I don't care what t is. Okay? Right? So regardless of the value of t, it has to be 0. So how do you make sure that the left hand side is always equals to 0? Okay? Regardless of the value of t. So as usual, you can see that this means that your I will be 0, right? So once your I is 0, this term will be 0. Okay. Now over here, this is just 0, right? Sine 0 is 1. Sine 0 is 0. So you're left with just b. right? So this is equals to 1. Okay, maybe I just help you to see better first. Let me just, so let me simplify from here first. So this just means I times j plus kt plus, so this is 0, this is just b times 1, so this is omega over c times b times c cos omega t plus d sine omega t must be equals to 0. Okay, so remember this small c and this big C are different. Okay, the big C is a constant that comes from your general equation. This small c is part of your wave equation. Okay, so the value of c is normally given to you together with your wave equation. Alright, okay, so now again you need to keep the left hand side 0. Okay, left hand side must be equal to 0 regardless of the value of t. Okay, so now I hope it makes it clearer. You can see that this can happen if your I is 0, okay, and your B is 0. That's all you need, alright? You don't have to make J, K, C, D all equals to 0, alright? So again, you can see if you had made J, K, C, D equals to 0, you have J, K 0, C, D 0, and your solution would just be 0. Not very useful. Okay, so all I need is for I and B to be 0. Okay, so I just need in the general solution, equation 1, I to be 0 and B to be 0. Okay, so I'm going to put I equals to 0 and B equals to 0 into 1, and then this gives me the new solution. Okay, so this H J plus KT plus, so the B is also gone, A cos omega x C cos omega t plus D sine omega t. Now I'm going to bring the H in, so I get Hj plus Hkt, and I'm going to bring the A in, alright? So I get AC cos omega t plus AD sine omega t. Okay, so again, I'm just going to name this J prime, I'm going to name this K prime. I'm going to name A times C as C prime, A times D as D prime. Okay. So this just becomes J prime plus K prime T plus cos omega x over small c, C prime cos omega t plus D prime sine omega t. Alright, so this is my new solution, right? Or updated solution. Okay? Right? Updated with the information I equals to 0 and B equals 0. Okay, so now I'm left with J prime, K prime, C prime, D prime, and omega to find. Right, so I've used my first boundary condition. Okay, now I'm going to use my second boundary condition. Okay, so second boundary condition tells me u equals to 0 at x equals to 1. Okay, so that's what I'm going to do. I'm going to put my second boundary condition, u equals to 0 at x equals to 1, into my updated solution, which is equation 3. Alright, and then you will see what happens. So I'm just going to put x equals to 1 here. So I get j prime plus k prime t plus cos omega x is 1, so it's omega 1, okay, divided by c. Now c prime cos omega t plus d prime sine omega t, and this has to be equal to 0, right? Because when I put x equals to 1 into my solution, u has to be 0. Okay? So again, remember, this has to be 0 regardless of the values of t. Okay? This is omega. Right? So regardless of what I put t here and here, it has to be 0. Okay? So you can see that you have no choice to make this j prime plus k prime t equals to 0 for all values of t. Your j prime must be 0, your k prime must be 0. Okay? Now, if you make c prime and d prime 0 as well, okay, there's nothing left in your solution again. You can take a look. If j prime is 0, k prime is 0, c prime and d prime are also 0, there's really nothing left in your solution. So instead of making c prime and d prime to be 0, what you should do is actually to make cosine omega over c to be 0. Okay? Alright? Okay. So how do you get cosine omega c to be 0? Okay. For cosine of an angle to be 0, okay, this means that the angle now is omega over c, okay, the term inside cosine, it has to be an odd number of 90 degrees, right? Odd number of 90 degrees. So you can see cos of 90 degrees is 0, cos of 3 times 90 degrees, which is 270, is also 0. Okay, right? And then cos of 5 times 90 degrees is also 0. Right? So this means that I have to have an odd number of 90 degrees, or 2n plus 1, okay, of pi over 2. Right? Okay, so odd number of pi over 2. Okay? So n is now 1, 2, 3, and so on. Okay. So now I'm ready to put all this into my updated solution. So I'm going to put all this information about j prime 0, k prime 0. So my updated solution is 3. So these two terms becomes 0, and my omega inside here now has these values. Okay, has these values. Okay, so sorry, one more step. So omega over c equals to this, means omega is then 2 plus 1 to n plus 1 over 2 times pi times c, right? So I'm just bringing the c over. Okay. Alright, okay. Now, okay, so let's move on. So I'm going to put all this information about k prime, j prime, and omega, okay, back into equation 3. Okay, so therefore my equation 3 becomes u just equals to, okay, cos, okay, omega x over c, then just becomes 2n plus 1 over 2, so this is omega, right, divided by c, so this c goes away, you have an x there, x. Okay, and then you have c prime cosine. So omega again is 2n plus 1 over 2 pi ct. Then the d term plus d prime sine omega t, so it's 2n plus 1 over 2 pi ct. Right? So this is what equation 3 becomes, and remember your n takes on the value of 1, 2, 3. Right? So again, this value of n equals to 1 gives you one solution. Okay, and you put n equals to 2 inside here, it gives you another solution. You put n equals to 3 inside here, it gives you another solution. So you have many solutions. So as explained before, when you have many solutions, take all of them. Right? So we sum them all up. Okay, so n equals to 1 to infinity. Right? So remember to now your coefficients, your c prime and d prime. Okay, they depend on what value of n you put inside. Okay. So now this then becomes your updated solution, solution 4. Okay, so what's left to find now is your values of cn's and dn's. Okay, so this is where you start using your initial conditions. Right, so you have initial condition 1 and initial condition 2. Alright. Okay, then this is a bit messy here. Initial condition 2. Okay. Right. So initial condition 1 needs you to make use of du dt. Okay, so I'm going to find du dt from equation 4. Okay. So this means that from 4 you can actually find what du dt is. Okay, so now I'm going to differentiate with respect to time. Okay, so these two terms. So you have n equals to 1. This term we don't touch. This term has no time in it. Okay, so differentiate with respect to t. You will find that cos becomes minus sine, right? So you still also need to take out the constant in front of t. So you have minus sine, you have 2n plus 1 over 2 pi small c, right? Then big C prime n. So cos becomes minus sine, right? 2n plus 1 over 2 pi ct. Alright? And then for the d term, when you differentiate sine, it becomes cos. So you have to bring out the numbers in front of the t, which is 2n plus 1 over 2 pi c, right? D prime. Okay, so you differentiate sine, it becomes cos 2n plus 1 over 2 pi ct. Okay, alright. Okay, so this is my du dt. Okay, so I'm going to start putting in my first boundary condition, first initial condition. Okay, du dt equals 0 at t equals to 0. Okay, so then copy that. Okay, I'm going to put initial condition 1, which tells me du dt equals to 0 at t equals to 0 into equation 5, right? Equation 5 is the one du dt. 5, okay, t, okay. Right, so what does that give me? So all I have to do to equation 5 is to put t equals to 0. Alright? So I'm going to do that. 2n plus 1 over 2 pi x. Okay, then I have this term here, minus 2n plus 1 over 2 pi c prime n. sine of 0, right? T is 0 here, so it's sine 0. Sine 0, and this term here becomes plus 2n plus 1 over 2 pi c dn prime cosine of, and put t equals 0 here, is just 0. Okay? And this has to be equals to 0, right? Has to be equals 0. Okay, so again, sine 0 is 0, cosine 0 equals to 1. So this means that, okay, I'm going to take this term, these numbers in front. Infinity. Okay, so we have, I'm going to take these numbers out in front. 2n plus 1 over 2 pi times small c dn prime cos 0 is 1 times this cosine 2n plus 1 over 2 pi x. Okay, now this has to be 0. Again, it has to be 0 regardless of what values of x you put inside. Okay, so no matter what value of x you put inside, it has to be 0. Okay, so you can see that you have no choice. Your dn has to be 0. Okay, so you can put dn equals to 0 into equation 4 here. Equation 4 is actually your solution. It's just that you do not know what cn prime and dn prime are. Okay, but you have just found that dn prime is 0. Okay, so you put your dn prime equals to 0 into equation 4. Okay, and then you get your updated solution. Okay, uxt is equals to, right, n equals to 1 cosine 2n plus 1 over 2 pi x, okay, times cn prime cos 2n plus 1 over 2 pi ct. Okay, I'm just copying from here, right? And your dn is already 0, so this term is gone. Okay, so this is your updated solution, okay, which I have to call 6 now, right? So the only thing you do not know in your updated solution is cn prime. So now we have already used boundary condition 1, 2 and initial condition 1. The only thing left to do is your initial condition 2. Okay, alright. So initial condition 2 tells you that when t is 0, your u must be equal to this. Okay, so I'm going to put IC2 into equation 6. Okay, alright, IC2 is a bit long for me to copy, so I'm not going to copy IC2. So all I'm going to do is I'm just going to put t equals to 0 inside equation 6 here, okay, and equate it to this 3 cos pi x over 2 plus 6 cos 5 pi x equals over 2. Okay. So this means that, okay, so I'm going to put t equals 0 inside here, so you get this. Okay, so this is cn prime. So put t equals 0 here is just cos 0. Okay, and what must this be equal to? Well, this must be equals to this. Okay, up here. 3 cos pi x over 2 plus 6 cos 5 pi x over 2. Okay. Alright. Okay, so cos 0 again is 1. Okay, so now this means that I have, okay, so I'm going to bring the Cn prime term right to the front, so I have Cn prime cos 2n plus 1 over 2 pi x, okay, is equals to 3 cos pi x over 2 plus 6 cos pi x over 2. Okay, now this is not a cosine series, this is not a sine series, right? So how do you find the Cn prime? Okay, you actually find the Cn prime by inspecting the terms. Okay, what do I mean by this? Let me expand this term out. Okay, let me expand this term out. Okay, so I'm going to expand this term out. Okay, so when n is equals to 1, I will just get C1 prime cos, so 2 times 1 plus 1 is 3, right? 2 times 1 plus, hold on. Okay, hold on. I made a mistake here. Okay, let me see. Yes, I made a mistake. Okay, let me show you where I made a mistake. Okay. Okay. Alright, actually I made a mistake here, sorry. Okay. Right. Okay, if you remember when we got cos omega over c equals to 0, right? I told you that for cosine of an angle to be 0, the angle must be an odd number of n pi. Right? So if that means that your angle has to be pi over 2, 3 times pi over 2, 5 times pi over 2. Okay, now I shouldn't have started at n equals to 1. Okay, I should actually have started at n equals to 0. Right? Because you can see that if I start at n equals to 1, okay, the first term I get is 3 times pi over 2. Right? I'm missing the 1 times pi over 2. Right? Okay, so because cosine of pi over 2 is 0. Okay? So I should have started from 0 and not 1. Okay, again, okay, cosine of, if the cosine of the angle equals to 0, that means the angle can be pi over 2, 3 times pi over 2, 5 times pi over 2, 7 times pi over 2, 9 times pi over 2, and so on. Right? Now, so if I write it this way, okay, if I start with n equals to 1, I'm actually missing the term where omega over c is equals to pi over 2. So I have to start from 0. Right? So that is a mistake. So all you have to do is just remember, for this question, you have to start with n equals to 0. Okay, so correction here is you start with n equals to 0. Alright, that's all. Okay. Okay, alright, so let's go back to the last slide. So all this will be starting from n equals to 0. Okay. think that's all the corrections I have to do. Right, all the corrections I have to do. Okay, right. So now I have this left hand side must be equal to this right hand side. Okay, this is from initial condition 2. Right, so as I was saying, okay, right, let me expand this term. Let me expand this term. Okay, so when n is 0, you just get c0 prime cosine, so n is 0, this is just half pi x. Right? And then when n is 1, you will just get c1 prime cosine. So 2 times 1 plus 1 is 3. So 3 over 2 pi x. Okay, and when n is 2, you will get c2 prime cosine. 2 times 2 plus 1 is 5. So 5 pi x over 2. Alright, and then and so on, right? So let's do one more. So when n is 3, you get cosine 2 times 3 plus 1. Okay, 2 times 3 plus 1 is 7. Okay, and so on. Okay, so this term expands out to this, and if this must be equal to this, it means what I've expanded out here, it has to be equals to 3 cos pi x over 2 plus 6 cos 5 pi x over 2. Right? So you can now compare this cos pi x over 2 term actually is this term. Okay, so your cos 5 pi x over 2 term is actually this term. So what does that tell you? That tells you that my C0 term, this term, has to be 0. My C1 prime must be equals to 3. Right? This must be equals to 3. And my C2 prime, this term, must be equals to 6. Right? And all my other terms. Okay, all the higher terms. They are all equals to 0. Okay? Right, so if you take a look at your solution, okay? Alright, so your solution is actually equation 6. Where's my equation 6? Up here, okay? Alright, we look at equation 6. This is solution, okay? You only have non-zero C1 terms and C2 terms. Right? So therefore your solution becomes, okay, so you don't have to worry for terms from 0 to infinity. You only need to you only have 2 terms that are non-zero. The C1 when n equals to 1 and when n equals to 2. So when n is equals to 1, you will just get cosine, right? So n is equals to 1. So 2 times 1 plus 1 is 3. 3 over 2 pi x. Okay? And when n equals to 1, C1 is 3. 3 cosine, so again 2n plus 1, when n is 1 is 3. Okay, that's one term. And the other non-zero term is when n is equals to 2. Okay, so when n is equals to 2, 2n plus 1 becomes 5. C2 is 6, and this becomes cosine 5 over 2 pi ct. Right, so this is your solution. Okay? Alright, that's it for question 3.